again, initial energy should be equal to final energy. Okay, initial energy means energy at this point. Final energy means energy at C. Okay? Now, initial kinetic energy plus initial potential energy should be equal to final kinetic energy plus final potential energy. Okay? Again, at this level, you know kinetic energy is 0. So this is equal to 0. Now, let's write the remaining parts. Potential energy we have because we have height. Potential energy is M times G times H will be equal to potential energy at this point. Okay, then 1 over 2 into M into VC square plus M times G times H of C, H of A. Okay, now you see again we have common factor mass cancel. Now we calculate remaining parts. G, you know, 10 Newton per kg times height of point A is 20 meter should be equal to 1 over 2 VC square plus 10 Newton per kg times height of C is 15 meter. 15 meter. Okay. Now left side becomes 200 and here we have 150. It is 200 and it is 150. 200 minus 150 becomes 50 Newton meter divided by kilogram is equal to 1 over 2 VC square. Okay, again, if we use Newton's second law here, okay, then it becomes 50 meter square divided by second square, and after doing cross product, it becomes 100 meter square divided by second square is equal to VC square. If we take under root both sides, then VC becomes 10 meter per second. Okay. Example number 5. A particle of mass 5 kilogram is released from point A. Okay, from this point. On a frictionless track shown in the figure, find the particle's speed at points B and C. Okay, at two different points, we should calculate the speed of the object. Part B, the net work done by the force of gravity in moving the particle from A to C. Total work done also we should calculate at point C. Okay, now first of all, let me calculate part A. Part A. Again, we have to use the concept of mechanical energy, conservation of mechanical energy, right? Conservation of mechanical energy says that initial energy should be equal to final energy. Now, initial energy means energy at point A. Okay, energy at point A. That is kinetic energy plus potential energy. So, kinetic energy, initial kinetic energy plus initial potential energy should be equal to final kinetic energy plus final potential energy. Okay, now you see at point A, obviously speed is 0, then it becomes 0. Next, potential energy, initial potential energy means potential energy at point A. Then M times G times H of A should be equal to 1 over 2 times M times V at point B, VB square, plus M times G times H of B. Okay, H of B. Now again, common factors we have, you see, masses cancel. Now we take only remaining parts. Okay. G, how much you know, 10 Newton per kg times height of point A is 5 meter. 5 meter is equal to 1 over 2 VB square plus 10 Newton per kg times height of point B is 3.2, right? 3.2 meter. Now you see, it becomes 32, right? It becomes 32, but this one becomes 50. 50 minus 32, 18, right? So 18 Newton meter divided by kilogram is equal to 1 over 2 VB square. Again, use here Newton's second law and you will get 18 meter square divided by second square. Now if we do cross product, then 2 times 18 becomes 36. 36 meter square divided by second square is equal to VB square. Okay, from here, VB is equal to 6 meter per second. Okay, this is speed of the object at point B. Now, dear students, I erase the board. You should complete your chapter. I solve the speed for the speed of object at point C. Okay. Still, A part continues. Again, we have to use conservation of mechanical energy. Okay. Initial energy should be equal to final energy. Initial kinetic energy plus initial potential energy should be equal to final kinetic energy plus final potential energy. Again, initial energy means energy of object at point B. You know at point B kinetic energy is 0 because speed is 0. Okay, next we have to calculate now. Potential energy, initial potential energy means potential energy at point B. So M times G times H of A should be equal to 1 over 2 M times VC square, because now we are dealing with point B, point C, okay? Plus M times G times H of C. Okay, again, we just cancel common factors, mass cancel. Remaining expressions will be G unit 10 Newton per kilogram. Height of point A is 5 meter. Should be equal to 1 over 2 VC square. VC means velocity at point C, right? Plus 10 Newton per kg times height of point C, it is 2 meter, right? Now, you see it becomes 50 and this one becomes how much? 20. 50 minus 20 becomes 30, right? So 30 Newton meter per second, sorry, per kilogram. Here we have kilogram, right? Kilogram is equal to Vc 1 over 2 Vc square. Now if we do cross product and use Newton's second law here, if you use Newton's second law here, then we will get 60 meters square divided by second square is equal to Vc square, right? Now if we take this both sides under root, then we will get Vc is equal to Vc is equal to 7.75 meter per second. Okay, this is velocity of object at point C. Now I erase the word, dear students. I solve B part. Okay, B part. You should complete your chapter, dear students. Now we go for B part. Okay, B part. B part says that the net work done by the force of gravity in moving the particle from A to C. Okay, we can use few different methods. First, best method is work energy theorem, as we discussed in previous classes, right? Work energy theorem says that the work done on an object is equal to the changes of kinetic energy. Or we can use potential energy also here. Okay, let's use work energy theorem. Work energy theorem says that work done is equal to changes in kinetic energy. This is simple one. Okay, work done is equal to changes in kinetic energy means final kinetic energy minus initial kinetic energy. Okay, work done is equal to 1 over 2 m times v. Here final means at point C, right? Final means at point C. Then Vc square minus 1 over 2 m into Va square, right? You know velocity of object at point A is 0, then this total expression becomes 0. Now work done is equal to 1 over 2 times m is how much? 5 kilogram times velocity of object at point C is 7.75 meter per second whole square. Now if we use our calculator, we will get the work done as 150 joules. Work done is equal to 150 joules. Okay, it is around 150 joules work done. We can use the concept of potential energy also here. Okay,